Okay, hello friends. This video is about a new model of the universe called the cosmic expansion model, and it reveals uh, the correct interpretation of results that came to be known as Einstein's theories and the Standard Model. So this is way over a lot of people's heads, I know. So you have to have at least some background in physics and a lot of math and science history maybe to get a handle on what I'm trying to say. Given that background, I'm sure that I can lead you to a new understanding of the universe and a fourth dimension. And I can prove these things. So I'm going to do that. I'm going to go back through the first ideas that are established facts, physical facts that were used to verify Einstein's theory of relativity. And I'm going to also prove that you've been bamboozled. We've all been bamboozled. A joke, a swindle, all of those things, as charged by Lewis Essen. But anyway, nobody's actually figured out what the heck is really going on. And finally, it just occurred to me. So I'm going to try to share that with you. So in this diagram or video I've got, well, let me explain a little bit about well, okay, let's just talk about the video for now. If you'll notice, there's a spiral. It's blue on one side and red on the other. You see this? This is a light wave escaping from, let's just say, the surface of the Earth into a long distance away where the gravitational field is less. Physicists know that the light that is shifted to the red is just leaving a large massive body, and they know it shifts back to the blue when it's coming back that way. So the redshift is what's always in the news. They're always talking about the cosmic redshift, which means that the universe is expanding and blah, blah, blah. All this complete nonsense. But I'm going to try to walk you through the only real interpretation of these physical facts that you can actually have. And so it's blue on the one side and red on the other because, of course, it shifts towards red on leaving. It also accelerates on leaving. This is a known fact. And that's what I'm trying to depict here. So this little electron is in an atom is going up and down from one orbital to another. And with every up and down, it's giving off a quantum or a packet, a photon of light that's turned into this wave that's being propagated through space with a certain wavelength. And it's blue when it starts and it's red when it ends. I mean, this is a very magnified world, okay? This is very, very extremely exaggerated. This is what's going on, and I just need you to be able to see that. And these clocks, notice that at the higher elevation, the clock is running faster than the one at the lower elevation. Okay, this is important to know. Now I want you to imagine that you are standing on Earth, you know, on your side, I guess, in the direction of this light beam. So you're standing there, but you're being held down by gravity. And I want you to imagine that you have a scale or a ruler. Let's say a ruler. And you take that ruler and you bend down towards your toes, and that ruler actually does shrink. You know, very tiny amount, not this much, but we're trying to make a point here, okay? It does shrink. and clock speed also slows down. And a couple of experiments to demonstrate these things were taken as validation of Einstein's theory of relativity, in that he predicted them or something. Okay, we don't want to talk about or think about relativity. The world is in a very, very black hole of confusion. We just don't even want to go there, okay? We want to see for ourselves what's actually happening rather than learning in school what we're being told, okay? So, anyway, this light beam is accelerating. Now, and you can see these things. The clock is running fast. This one down here is running slow. And I didn't do too bad a job, did I? Huh? Okay. Now, we want to talk about a couple guys named Michaelson Morley, the most famous experiment of all time, excuse me, that was ever performed, that validated Einstein again, and of course his theory of relativity, whatever that. Don't go there, okay? Black hole, black hole. So yeah, Michaelson and Morley came along, and what their role in all this was is they wanted to measure the direction of light in 2 or 3 different directions, because all of physics world at that time believed light had to be transmitted, as all waves are, in some sort of medium. And the Michelson-Morley, an ingenious experiment, okay, that sent a beam of light in one direction and another beam in another, and measured comparatively, if there was any difference in velocity, and they discovered there was none, which leads you to believe that there was no ether. And of course, this was another card that Einstein was holding. Oh, look, there's no ether. See, okay, I'll give you another ticker tape parade in New York, like you did in the what is it Kensington expedition or whatever. I forget now. But anyway, okay. So we have those facts established that light is the same in all directions. Of course, they had this thing sitting in a vat of mercury, and so it was level. I mean, wouldn't you ask yourself the question, what if they aimed it down? Does it have to be perfectly flat with the Earth? And of course, we're going to find out that at any given gravitational potential or gravitational gradient, there is a certain now what am I going to say? Okay. At any certain gravitational potential, you're going to have a constancy of the speed of light. Okay. But what about if you turn the thing on its side and it's going through a different gravitational potential, or maybe one beam goes straight up and down? It's shorter, right? Based on what we just talked about. I mean, Einstein proved this stuff. Everybody knows this stuff. Okay, so, but wait a minute. Well, let's just stop and think before taking the path down, and we're the photon, okay? We're going not as far, we're only going 2 feet instead of 3 feet, okay? But our clocks are only running 2/3 as fast. And so you can only define a meter by the time it takes for it to crank out a certain number of wavelengths of iridium or lead or whatever it is they're using these days. And so, it just turns out that a meter always measures the same, no matter which gravitational potential you're in locally. I mean, if you're taking the meter, you and the meter are growing at the same time. You understand that? So maybe from a very remote perspective, you can see the difference, but not if it's you going up and down. This is important. See, this gets to the root of the thing, and they don't talk about these things very much. I think it's quite deliberate. But anyway, who knows? We all live in a black hole, I'm sure of it. So anyway, Michaelson Morley came up with that result, but then we find out later, you know, from a remote perspective, and this is part of Einstein's works, that this light beam is actually um, accelerating, it's traveling faster, and actually an incoming beam is actually going slower. Well, you know, I mean, cutting to the long and the short of it, obviously there's a gradient. Obviously something is transmitting light. It's not just going through open space. But here's the thing. Um, this redshift that we're talking about, so if I can get you to understand this for a minute. This redshift, they call this a gravitational redshift. You're familiar with the regular Doppler redshift, right? A train goes by and the whistle is and just as it passes, it goes wah, wah. Okay, that's the Doppler shift. Okay, the wavelengths get stretched out because of the speed of the train approaching. They're being squished up, and when it passes, they're being drawn out, and so the volume of the sound goes down. And that's a Doppler redshift also. You get a redshift from recessional velocity. So you get that same redshift, but this is a gravitational redshift. Yeah, it's different. Oh yeah? Well, I kind of don't think so. But anyway, um, that gravitational redshift, that'll tell you how fast a person is falling, acceleration due to gravity at that point, wherever it is. You know, that's pretty cool, huh? You can actually figure that out. Uh, you know, not that it might not be a little bumpy along the way. I don't know, millions and billions and trillions of miles and stuff, and things aren't the same now as they were then, but still, you know. Um, so anyway, Michelson and Morley found there was no difference in which direction it go, but we know that there's a difference in velocity if it's going down or up, at least from a remote observer. And we stop to think, oh, this interferometer, you know, it was a local observer, not a remote observer. If we were watching this interferometer from way back out here, we would see that at least we see that the speed of light is just going too fast coming up and too fast going down. And, you know, there is an ether. There has to be an ether. So how does that work? And here's the riddle. Here's where we're going to crack the case, okay? Just bear with me. I've got to try to convey this to you properly. The frequency change, okay, is speeding up that in one direction, and it's being assisted by a current in one direction, gravitational current leaving, and it's being impeded by the same ether current, I guess you could say, going the other way. And what does that tell you? Well, it tells you that a stream of ether is pouring out of the center of the earth, right? I mean, it's blowing right by you. Oh, I should tell you, we've got to use this. We got to put a rocket ship on here. See, so you get into this rocket ship that you're sitting on Earth. Okay, this will help you understand it. And you have a special window, and you open it up, and you see the ether passing by. Okay, this is what's transmitting the light, actually, and it's actually because you're expanding away from the Earth. I mean, because the current of ether is passing you by, there must be a ton of ether coming out of the Earth right away. That obviously doesn't make sense. The only other alternative, okay, this is where the old model breaks. Okay, you've got to think about this. The only other possibility is that the Earth is expanding. And here's what I got to tell you, that Einstein wrote a paper or something, or was quoted somewhere in saying just exactly that when you fall, you don't fall. It's actually the Earth expand. I don't know if you used the word expanding, but the Earth accelerating upwards to hit you. All right. He really thought that, huh? Well, see, that's just it. I think he knew a lot that he wasn't telling because he wasn't telling the truth. Because maybe it's just that if he had said anything about expanding, uh, cosmic expansion, that he would have lost credit to a man named Friedman for coming up with these ideas. Well, I don't know for sure, but that's just a guess. I mean, it's in the wind, right? Okay, anyway, getting back to this, if we're expanding, but we're not expanding, but we are expanding. Okay, let's stop and think about this. Let's give this a lot of thought. Let's suppose that we can't see the expansion locally or inside the universe simply because, or for any where we're a local observer, and that's because all bodies of mass are expanding outwards. And they're expanding in such a way that they look more distant as they go. And that Doppler shift in the fourth dimension, that's what accounts for the gravitational force in our dimension. It's a give and take. And I know this is something you never thought of before. That's the only possibility. And this is why we have a proof here. And no, the physicists aren't invited to the party. They've been far too brainwashed for far too long, and they have kids to feed. God, but the mathematicians, the good mathematicians out there know a little bit about science and physics. They can help. And they can tell me I'm right. All you have to do is look at this, what's going on here. Okay, the ether is fixed, and we're flying with the space, assisted by the expansion of space in the fourth dimension, going outwards. This is a dimension that we actually live in without seeing it or feeling its presence. It's inferred from the redshift data. Now, they want to put in your mind that this means that this is recessional velocity and all of the, when things used to be all together, and not that not that didn't happen, but cosmic expansion doesn't work like that. As we're just like a guy going up and down the gravitational potential with a ruler. The universe would have always measured the same. If we're talking about cosmic expansion, cosmic redshift, that's not cosmic redshift. This is cosmic redshift. All mass of the universe, property of all mass of the universe is expansion. Okay, you understand that? In the fourth dimension, and because it's the fourth dimension is weightless, and you're expanding. See, we have dual dimensions here. What is Doppler redshift in the fourth dimension is gravitational redshift in the physical universe. So there's two dimensions here. See, and ether is always fixed relative to the speed of light, but the expansion due to matter in that locality, the gradient of gravitational contours out there are going to dictate how fast matter is expanding. And oddly enough, black holes are expanding faster than everywhere else in the fourth dimension. But that translates mathematically and conceptually directly into gravity in our dimension. What's Doppler shift up there is gravitational redshift down here. So that's where we start. And then we have a real physics, okay? Then we have real astrophysics, then we have a better perspective on what we're doing, space-wise. When we know that there's a fourth dimension, which, oh, well, of course that's not occupied with Well, now wait a minute. Okay, the ether isn't in this dimension. It's in a different dimension. We have no idea what's up there. Well, I think a lot of people who've had near-death experiences know. But our universe is inside of a larger universe. And so it's both outside of us and it's um, up, because it is up. I mean, if you understand, if you have any feel for it, it's up because we are inside. We're dependent. I mean, this is our mother sphere. Oh, and you think that would be unoccupied, do you? How about that? When you were a chicken and the egg, did you ever suspect there was anything out there? But no, you know, use your head. There is a fourth dimension, and it is the medium through which light is transferred. It is not propagated in this dimension, and that is the only solution to that problem, not relativity. And so the cosmic expansion model of the universe is correct. I just want you to know that, and I want you to talk to me. I want you to tell other people. I want you to study it. You think about it until you realize, until you're entirely sure that I am correct. And I'm signing off right now. I've got dinner on the stove. Okay, thank you.